let's start. So I introduced this hashtag on Twitter, Year of PWA. You will understand in a few moments why. Could we call this 2018 as a real year of progressive web apps? And let me give you latest status and latest news, what's going on this field. But before that, let me remind you, let's recall altogether what is PWA at all. Here I will not give you like article from Wikipedia with these 10 classical characteristics of PWA. No. Let's have a look at what the folks from Mozilla Developer Network wrote with some help from my side. And these are just 2 sentences, right? But I'm responsible, like, really for each word there. So each word matters on this definition. So first, progressive is just about using idea of progressive enhancement. So it's that simple, right? We use modern APIs of modern browsers, right, to build our cross-platform web apps. Why do we do this? To entertain our users, to excite them, to give them good user experience, right, by using this features, functionality, which was previously available only on native mobile apps. And our apps, we want them to work everywhere. What do I mean by everywhere, by cross-platform in this context? Let's have a look at this table. First, we have browser. Yeah, we can argue and reason if this platform or not, but after all, we are talking about web apps, right? And web, like, came out from browser, right? So these are very interconnected things. First, mobile. Second, this is definitely a platform. And mobile platform actually was like igniter for a whole idea in general. Why? Because of 2 facts. First, our mobile devices, as a rule, not as performant as our desktops, laptops, right? At least not all mobile devices. And second, on the other hand, they are really rich in terms of interesting hardware features, right? Like regular phone is well equipped with a variety of sensors, possibilities to manipulate with media and so on and so on. And we definitely want to use all these possibilities in our apps. Desktop, we often forget about this platform while we are talking about progressive web apps, right? Because, okay, what to optimize there? Our desktops, laptops are quite performant, and they quite often connected to fast Wi-Fi networks, right? But still, it could be not Wi-Fi, but Li-Fi, right? When you see that it's connected, but in reality not. And why not to optimize what we could optimize in terms of networking, even in case of the fast network, even in case of reliable network? And why not to have apps, web apps, as like native apps for platform itself? Why not to jump away from the frame of the browser, right? Okay, so we have these 3, and with great pleasure, I can say that major browser vendors implemented at least basic features of what we call progressive web app. By that, I mean service worker. We will not go into details here, right? Because service worker is quite a large API specification, and obviously not each browser has everything, right? But the basic stuff is there. Mobile, with the same, if not higher level of excitement, I can say that both main platforms are there as well. Yeah, this all happened really not so long time ago, just 1 month or 1.5 months when iOS 11.3 came to production. Before that, we could test all these features only in beta versions as developers. Desktop, it's really interesting that Microsoft is pioneering here, and already now you can install your regular web app, and I mean non-regular but progressive, without any wrapper over this to have it running as a regular app on Windows platform. And this is really interesting. Behind the flag, what do we have? Here is, again, Chrome icon, but this is Chrome OS in this context, operating system. It's actually not behind the flag, but in Canary channel, which is for like a special release channel for developers. And this summer, we'll get this in production. And on the same cell, I could say that, sorry, yes, we are here. Using Chrome browser, not operating system, you quite soon will be able to install your progressive web apps as like first-class citizens, as real apps on your Mac OS-driven devices and your Linux-powered devices. Right now, this functionality is behind the flag. Cool, but I have one more line on this slide which is empty. What could we put here? This is not a platform in full sense, right? This is not the place where we run and install our progressive apps, but how do we distribute these apps? It's also very interesting that Microsoft is pioneering here again. With Microsoft Store, we have quite interesting possibility to have one more channel to distribute our web apps without any effort from our side. So we just create a JavaScript application, progressive one, put it somewhere on internet, and Microsoft's spider called Bing will sooner or later it will check your app, and if it follows some criteria, like simple ones, driven by service worker, has proper app manifest, like not offensive content, so all this regular stuff about all regular stores, then it will be there. And just imagine when in morning you wake up and you got 10,000 more users of your web app, web service, then yeah, it could be scary, it could be exciting, but anyway, of course, you can go and like claim this app and to manage this app, or you can remove this app from Microsoft Store if you wish. So the picture is really shiny at the moment. It was about cross-platform part of the definition. What about UX, user experience advantage I mentioned? In very big picture. First, what first pops up in the mind when we talking about service worker is all the interesting stuff about networking, right? Including running in fully offline mode. If we online, why not to stay connected with our customers, users, by sending them some important notifications, right? It's all about web push, also something really new for web, and many more cool things. We'll list only a few of them in the end of our session. It's all driven by service worker, our today's hero. And fourth part of PWA cool UX things is proper app experience. What do I mean by this? Is absence of any kind of store, if you wish, of course. So we could have this Microsoft Store, but it's absolutely optional, right? We deliver our app by just deploying it, and that's it. All internet users, they know what to do with search string, how to type your address. And this part of PWA driven by very simple JSON file following web app manifest. Okay, we got all this info we need, and we quite ready to dive into the service worker, which is heart and actually brain of progressive web app. This is not getting started with service worker session. This is why the intro will be just to recall you what is this in a largest possible picture. So we have our web app, we have network somewhere, our API or any other parts of internet, and our service worker somewhere in between. Both web app and service worker, they work inside our browser or web view, but they live in totally different contexts. Physically, if that's applicable to some bytes on your hard drive, this is a JavaScript file, and this is a worker. It means that it runs in a separate thread in your browser, and not regular worker, but event-driven one. First tip, just to warm up. We have to know what we can use inside service worker and what can't. And green items, obviously, we can go for them. Red, no go. And we can have this quite blurry conditional lines, what we could replace with what. You can easily notice that everything in green is asynchronous. And this is nature of modern web. This is nature of modern approach. This is why it's nature of service worker. Everything is asynchronous, event-driven or promises-driven, right? And you remember that progressive word in progressive web app definition is about progressive enhancement. So it's really important to go for feature detection before you even started to do anything there. Why? If we open this small utility called PWA feature detector, it's on GitHub, and you can check your own browser, we will notice that not everything implemented even in the most PWA-ready browser. And you can easily guess, even without reading this user agent strings on top, what is what here. Obviously, Chrome is like golden standard in terms of support, then Firefox. And as I mentioned recently Safari joined this game as well, which is cool, but now we have only offline capabilities there and payment request, right? And by the way, sometimes Firefox implements some specs or some APIs faster than Chrome. So this is a real kind of competition. Okay, so the simple code, how we register service worker, again, to just warm up a bit, we just use the classics of feature detection, right? We check if service worker in Navigator. We remember that we try to enhance our progressively enhance, but not like regressively degrade. So to avoid all these red lines in our log for browsers that still not support service worker or some parts of service worker, this is must have. Of course, yes, our code will not be so laconic, but this is life. So it was about service worker in general. Also, we have to check specific parts of service worker. As you already have seen, it's quite extensive API with many sub APIs, I'd say. In this case, this code sample is to check availability of background sync, which is at the moment implemented only in Chrome. It's not only about avoiding errors in our apps, but also we could hide or show some pieces of UI in the app. For example, if the browser does not support web push notifications yet, why to show this button subscribe to push at all, right? We can easily just hide this. And we can go even deeper and to check, say, sub-features of sub-feature, which is, for example, actions of notification API. Just to illustrate how that looks in Chrome, all these notifications, you can have a set of actions which user will get after clicking the button. It's not implemented in Firefox yet, so by checking this feature, we could maybe introduce some other UX approaches, right? So it was about registration itself. Now let's speak about when to register this. The rule of thumb is the later, the better. Why? Because we are talking about progressive enhancement again, right? So it's should be okay if some pieces of service worker or service worker in general will fail for some reason. It should not affect the overall flow of the app. So please don't rely on all these service worker features. And during the startup of the app, it's crucial to put all the resources to show something on the screen, right? So there are many user research showing like if something not ready in some milliseconds, then user will go to your competitor, right? And let's make the way the service worker not to compete for network resources, for CPU resources with our main thread of app loading. Luckily, it's quite easy to achieve. So this is code you already have seen. We check the feature. If it's there, we register. And if we check what's going on in network tab of DevTools, we'll see that in this sample, logo PNG will appear the last. Why? Because service worker started its own work by caching resources, by putting all this to special storage called cache. So it's for its like internal needs for the next start of the app. But on the same time, we just ruined our first load experience. This is a simple example. Just logo did not appear, but it also not so good, right? Luckily, it can be easy fixed by just adding one more wrapper, which is event listener for onload. And then we'll see totally different picture. So we load our app as regular. Then we'll see logo PNG. And obviously, only after then, service worker will start its work. We could easily recognize what requests are going from service worker by this tiny icon in front of file name. If we are talking about some specific frameworks, in my case this is Angular, it's even better to postpone it even further than not just on load, but when your app's UI was rendered. So we just avoided competing for network resources. Let's avoid competing for CPU resources, right? So modern frameworks, they are quite demanding in terms of like building the UI. So it's, after all, JavaScript puts your buttons and form elements on screen. So if you register third-party service worker, not the internal one, in your Angular app, just make sure that it was registered after app loaded, rendered, ready to use. Then we can do all these progressive enhancement features. Good. So now we are good to go with registering. What will happen if we need to unregister service worker? Right? It also might happen. And we are developers after all. We introduce bugs, and something could go wrong. And we definitely have to have some saver in this situation to avoid pictures like this. So yes, suddenly your website could just break if it's driven by service worker and you we were not very careful about following some updated specs. So we have to have a rescue plan for that case. First, what pops up in mind, if we can register service worker, we can unregister this, right? To make our progressive web app just web app. Yes, but why do I have question mark here? Because to unregister service worker, you have to unregister service worker. And this is kind of recursion or chicken and egg, you name it. Why? Because in most cases, we use service worker as something that serves previously cached version of our app, say index.html, from cache, right? And to have unregistered code in this index.html, we have to update index.html, but even if we put the one to our server, if we deploy this, it will be still driven by our old and, say, broken service worker. What's to do in this case? Update service worker itself. We could fix it, or in case of like super emergency, we could just put no operational one. But in that case, we have to make sure that browser will understand that it's time to check this service worker, because it follows regular HTTP cache. It's like different cache rules, except with one exception. So how this no-op service worker could look like? On install, we just using special method to skip all the waitings. So we are not going deep into lifecycle of service worker, but by this code, we can just explicitly say, don't wait anything, take this new service worker and push it to the browser. Good. In case of real serious emergency, we can even break our UI by refreshing all the windows we have. Yes, but then our user could get some unexpected impression what's going on. How to make sure that service worker updated by browser? So first, we can put regular HTTP header when we serve service worker JS file, right? But in some cases, and quite often, if service worker is more or less like functional, we use import scripts method when we import other pieces of our code to be registered along with our main service worker. What we could, and these ones are not following the byte difference rule. So browser will ignore, will just not perform these checks if something was updated in imported files. What we could do here, we could change the names of these files we import, or we could add this some hash when we import them. It's quite annoying, right, for us, for developers. Luckily, this specification was changed, and quite soon we'll have a special property which we could pass during the registration called update via cache, where we actually say what do we update via cache and what will be updated each time. And the values are imports, which is default one. As I mentioned, browser checks for only the main service worker at the moment, so the behavior will not be broken. But we will have all or none features in addition. And by the way, to illustrate my saying about browsers not quite often compete in implementing some features first, this already implemented in Firefox, but not in Chrome. That's interesting. Next, pre-caching. So I already mentioned that quite regular job for service worker to take some files, hopefully after our app was loaded and rendered, and download them again. So on the first load, user will get kind of double download of our app shell. This is a trade-off, but that's okay. Put all to the cache to make some offline magic, right? So we'll serve the app from cache if we don't have a network. What's the rule here? let's be careful with what we are trying to cache. To illustrate, let's pretend that we want to put some non-existing HTML file to cache, and the code is regular. On install event, we have a method called addAll, which takes a list of resources and put them to cache. What we will see in our console log, service worker failed to register completely. According to the specification, if the promise inside the listener, any listener of service worker was rejected, it just unregisters service worker or not registered. This is more correct wording. This is again like some part of specification to avoid like some unintended errors, right? It's okay if service worker just failed. We just not will get progressive enhancement of the app, but we have to try at least to avoid this. What could cause this error in the moment when we just start it? HTTP errors, all kind of like 404, 500. Just all non-200 responses. Also, we cannot run service worker for forever. This is event-driven worker, right? So to avoid like battery draining and the resources consuming, we limit execution time on this. And after all, our storage could be full and no place to put our app shell or resources or whatever. How could we check what's going on with our storage and which are the limits? And they are different for different platforms, for different browsers, and even methods of the calculation is totally different. Luckily, we have special API called Storage Estimate API. So if you're unsure about putting some more or less large resource to cache, you can just check it. But rule of thumb, don't overuse cache built into the browser. So yeah, that's really important. And of course, clean after yourself. If you put a new version of your client-side app, remove the previous one. So you as a service worker developer fully responsible for this. Next tip. Quite often we want to fetch and store in the cache some stuff from other origins, from like some CDNs, third-party API suppliers. We have to get ready for opaque there, which is part of HTTP standard, right? And we have two options here. We could add coarse headers to this, say, remote origin, but in most cases we don't have this privilege, right? We are talking about third-party stuff. Or we can handle opaque responses in our service worker. And the limitations of these responses are well known. So this is, in general, black box for our JavaScript code. We cannot even understand was this request successful or not. So it always just returns 0 as status. And obviously, all our methods like add and addAll will fail because they expect statuses from 200s range. What could we do in this case? Let's illustrate that as an example. Let's say we want to cache some file from some other origin. And what will happen in the regular code, like the one we had on previous sample. Again, log full of red messages, and service worker will just not be registered, so we lose all this progressiveness again. How to solve this? Handle these requests one by one manually. This is code sample from Workbox library with special mode called no course, which is quite self-explaining. So in this case, we don't have the privilege to use, these nice, useful methods like add and addAll. We just have to go through the files we want to cache manually. But of course, in that case, we have to be really careful about what we do later with these resources, because we don't have any idea was the request successful or not. We have something in our storage with status 0. Okay, so we illustrated just few of possible edge cases. Maybe they are like not edge cases, but a bit like something that goes beyond regular success story of HTTP request. You see that even in this naive code samples, we have to care about many things. So why not to use some tooling for automating our PWA features? Luckily, there are some nice options. And so let's understand why do we use some libraries, frameworks at all. First, we don't most likely want to implement another cache invalidation algorithm, which is the case if you wish to have a really optimized service worker. Then, if we are good developers and we love how this library works, we could go and check how it's implemented in that case. Most of these libraries are open source, luckily. And after all, I believe we all want to focus on our own tasks instead of solving another HTTP edge case. So this 3 is about tooling in general, but next 2 is related to service worker and PWA even more than to like regular tooling. First, PWA is a living standard, and updates happen, and unfortunately, even breaking updates. And most likely, we will have even more. So if you don't want to see content corruption error instead of main page of your website, so in that case, it was not just failed progressive enhancement, but ruined app experience at all. That also might happen. Let's rely on, say, proper tools from trustful developers. And many other edge cases. You'll see some more in the extended slide deck I mentioned. Luckily, we have a full set of tools for us. Every from major frameworks is equipped with PWA starter or template or some helper for you. We have also builders of our service worker. Again, you specify some parameters, and these tools, they build something working and something production ready for you. And we can check if our progressive web app good enough. A couple of words about some of these tools. Workbox. This is like de facto standard for modern progressive web app tooling. It offers quite rich functionality right out of the box, so you can automate at least basic tasks for your service worker with really 2-3 lines of code, and this is not actually code, but the code for configuration. But it has a real killer feature, which gives you possibility to not just build some service worker to plug into your app, but create your own service worker and extend it by these features. This is something unique, and no other tooling offer this way to build your PWA experience. PWA Builder, it's a website and a command line utility from Microsoft, which also gives you some interesting options to automate. But what's really interesting is this one. You can take your progressive web app, which is like will be just URL you give to pwabuilder.com, and it will build you binaries for you to distribute to app stores if you have this task, because that could be an interesting option, maybe temporary before all the platforms support all the features, or definitely not all the native apps functionality will be introduced to service workers and progressive web apps. So definitely, we still need sometimes native apps, right? So you just take this PWA Builder, and it's there. And it might look like something theoretical, but not. And there is a really nice article about practical approach to this tooling. And after all, you have a single code base with some wrappers over this. So this is this way to build native apps from your progressive web app, from your web app, is reality. And just super short about this linting or auditing tool. Both of them go as some browser services. Lighthouse now is part of DevTools. Before that, it was extension. But what really interesting for us, for developers, is CLI. So we can involve these tools into our continuous integration process. And during this Google I/O, it was introduced that Lighthouse updated to version 3 with more APIs exposable for developers. OK, so let's move slightly to UX part of our session and application update. Please, don't break the web in terms of freshness. What do I want to say? Just imagine, we have version 1 of our web app. We deployed it on server. Our user opens in the browser, and let's pretend that we have service worker, which was properly registered, and during the first load, grabbed all these resources we need to have to provide offline experience, which is, like in most cases, our HTML, JavaScript, CSS, something that we have to build and the wrapper, the app shell from, right? On next version, we fixed some bugs in our app. We introduced some new bugs. What will users see on the very first load after update? Unfortunately, version 1. It's a well-known trade-off for progressive web app, and we have to deal something with this. We have to at least improve the experience. And yeah, of course, on the second load, if we again build our service worker in a proper way, the user will see updated version. But what could we improve here? And I believe you've seen this approach many times on the modern websites. Something popping up like this, some message that a newer version of app available. And in most cases, it offers you to just refresh the page to get a new one. It's well-known trade-off for progressive web apps. But how to implement this message? You can do it manually. You need some exploration of service worker events, how to catch the event when service worker was updated and the new one is ready. Or, as I mentioned, you can go for some tooling. And in Workbox is as simple as providing the name of channel we listen in our client-side app and listen for the messages in this channel in our application. And we use broadcast channel API in that case. We can even go for some update strategies. When to do this, perform these checks? Obviously, we want to do it on application start. Also, if it's important for us, we can do this check by some period. So if a user has this tab open for, I don't know, days or hours, we update our app frequently, we can do this check. Or we can introduce some intermediate approach and do this check only on navigational request. Awesome. Next. As I mentioned, app is the first class citizen for at least some platforms now, and there will be more platforms later. It means that we can install our app, and let's take a proper moment for doing this. I believe you all seen this sometimes annoying message that this app could be installed, right? We can mimic this behavior as developers by opening DevTools and clicking at the home screen button. But this default prompt has issues. First, the moment of showing up is unpredictable. Next, it can interrupt your user experience, which is especially the case on mobile devices when it can take your meaningful part of the screen. It's hard to find this feature manually in the browser. It's well hidden somewhere in UI. And there are some alternatives proposed by browser vendors, like subtle button to have it somewhere on a status bar. Discussion is going on. What to do with all these cases, but how to deal with this right here and right now. We can listen for this event. We can prevent default appearance of this prompt, and we can show them this message only in the moment when we really need this. There are some open questions. Should we give the possibility to install, to show this message when we developers want, by passing some heuristics which is constantly under tuning up still, this standard is living. How to install the app without visiting this app at all, which is, could be interesting for some PWA stores which will appear quite soon, right? And for enterprise use cases, we might want to push these apps to our devices in automatic mode. So let's see, the time will show. Really short about what's going on next. What could we use except networking? First, we can introduce load balancer. We can intercept request in service worker, and it means that we can decide to go for server A or server B. Okay. Again, based on intercepting, we can easily organize client-side downloads of some sets we created in browser. Like we drove SVG file, and instead of going to server first and downloading from there, we can say get it straight from your client-side app by just providing some headers. And last but not least, really exciting feature, we can organize support of non-supported formats, like WebP in that case, with some power of WebAssembly, we can achieve this using service worker. My last tip, go to this resource. This is PWA Slack team, where well more than 1,000 developers communicate about service workers, and main folks from main browsers, frameworks are there. Also, yesterday, I started GitHub repo with a draft proposal for first ever progressive web conference. And on that, thank you.
Big applause for Maxim. Thank you.